deGrasse, Tyson.
Wow, thank you. Thank you for that warm welcome. I noticed a couple of you stood up when I came out. Thank you for that standing ovation. I'll work on everybody else. Just to make sure we are on the same page. You realize you have taken your Thursday evening to come to a theater to listen to an astrophysicist lecture for 2 hours. I don't want any misunderstandings about that. Okay? Do you know what the topic is tonight?
No.
Space, yeah, thank you. Yeah, space. Space, very good. The way this works is, I'm invited to a town, to a theater, and I give them a list of possible topics, a dozen or so, and then they pick one, and that's the talk that I give. Right? I'm not here to sell you anything. I don't think they're selling anything in the lobby, right? So I'm a servant of your curiosity. And so if you didn't know tonight what we're going to talk right here, right here. Okay? Well, this just in, the latest discoveries in the universe. Stuff you might have missed in the last 24 months. Which means this bounces everywhere because the universe is vast. And just to be clear, if you do not recognize these icons, I'm thinking you probably read. Okay? That's what I'm saying. I think that's probably what you do. Is this blocking the view of something? Just a little bit. Just a little bit. They originally set it up over here. And I said, no, I gotta be here. And so you were the casualty of this move. Okay? I have a question. I have a question that I haven't quite. Can someone explain to me Florida? I've tried. I don't. Is it just me? Here's a headline that, there is so much wrong with that sentence. That sentence should not exist. All right, okay. Florida just is what it is. I'm going to give you a table of contents tonight. And you'll see, if it's too small, I'll just read it out to the folks in the back row. But here's a table of contents. And there'll be some housekeeping I want to get through. There's a new telescope coming online, the Rubin telescope. There's new developments with satellites and their orbital debris. There's a fireball on Jupiter. We're going to see an image of that. Updates on the moon, the solar cycle. We're entering a new phase. New exoplanets. We discovered the biggest star in the galaxy. Black holes, Big Bang. Mexican alien mummies. Yeah, we're going there. Asteroid defense, I'm going to give a little reflection on the Space Force. There was an eclipse a few months ago, but there's also one in a couple of months, so I'm going to forward to that one to prep you for that. I just want to end with some reflections on life. So you'll get a sense of where we are in the presentation by this table of contents. Okay, so just some housekeeping, and let's see what we got here. Yeah, so it is true, often when an academic, which I am, comes to give a presentation, often the presentation is just a loosely veiled commercial for books they're trying to sell me, right? And so I just want to say, this is not really do that. This was the best-selling, it's a kid's version of this book, Astrophysics for Young People in a Hurry. This is if you're interested in history and war and astrophysics. This one I'm very proud of, Cosmic Perspectives. And this came out like 3 months ago to infinity and beyond. And now, I'm going to do something really crass, okay? Okay. I ask for forgiveness in advance. If you don't know what to do with that, ask someone half your age sitting next to you. So, the reason why I put this up is that will take you to a website that is the shop of the American Museum of Natural History, where I work. And that shop, I have an agreement with the shop where all the books of mine they sell, I had pre-signed with my fancy fountain pen. So, all my books are signed at that location, okay? But you could probably get the books for less on Amazon, okay? And have it delivered by the end of the but it won't be signed. So that's why I distinguish this, okay? All right. Continuing with housekeeping. Who here was dragged here by the person next to them? Raise your hand. I'm feeling you. Dragged here. Okay, so you have no idea who I am. You're dragged here. Welcome. Okay, everybody else who knows who I am will react to this next slide. And you won't have any idea why. Can we move on now? For those who didn't know, I was an accessory to the demotion of Pluto. I definitely drove the getaway car for this, on this scene of the crime. By the way, I know we're in Florida and everything, but Disney was fine with this demotion, okay? Mickey Mouse issued a press release saying, welcoming Pluto as the 8th dwarf. It's okay with Disney, but damn sure better be okay with you. All right, more housekeeping. Here we go. I have now a public service message from the James Webb Space Telescope, okay? On UFOs. It's a public service message, okay? Here it is. Okay, so just so you know, the James Webb Space Telescope is all that. Everything you heard about it, it's more than that, okay? It's working. And here is a model of the telescope. I was at a space conference a few years back. This was in Colorado Springs. And this is huge. And we say, how do we put a big telescope in space? We gotta launch it. The engineer says we know how to fold it. So this telescope folds into a rocket ferry. And we sent this thing 1,000,000 miles out into space. It's not like Hubble, which is orbiting low. It's 1,000,000 miles out in space, which means we can't service it, because that's not where astronauts go. So, but it's a remarkable instrument. And I want to show you just how precise our view is of the universe with it. This is the Carina Nebula. There's stars being born within this nebula, but I want to give you a sense of what field of view this is on the sky. So check this out. So we're going to zoom out from this. Okay, let's keep going. There we go. There it is. There's sense. There it is. At the tip of that arrow is what you were just looking at. But wait, there's more. You just look at the level of detail. This is 7,000 light years away. It's the central part of what we call the Eagle Nebula. It looks like an eagle, because we name things what they look like. It looks like an eagle, but on a much larger scale. This is deep in the center, and some people call this the hand of God. If God had 3 fingers, it'd be the hand of God, okay? So, I'm just saying, I'm just being honest. There's so much detail. We can zoom in, and there's like other gas clouds are there. Just look at that, okay? This is like thousands of light years away. So why is it? Oh, sorry. That was a Chinese Bible. To get rid of that, but that was stupid, wasn't it? If the James Webb Space Telescope can do this, why is it that the best evidence we have for visiting aliens is a fuzzy tic-tac, a monochromatic image seen by Navy pilots in our atmosphere? It's right there in front of the plane. Oh, I know. We should zoom in on it. Then we can see more detail. Like we just, oh, there we go. Maybe the aliens are actually fuzzy. That would make this a sharp image of a fuzzy object, right? That's how that would go. So I had to tweet about this. You know, they had the congressional hearings. Back row, I think about you guys all the time. Here we go. I'm thinking that if space aliens were actively visiting Earth from across the galaxy, we would not need congressional hearings to establish this fact. We are crowdsourcing any possible alien invasion. 3 billion photos and videos are uploaded to the internet every day. Does anyone have a non-fuzzy image of a UFO? Oh, you do! It's sharp? And you can zoom in? You do? Okay, I'm glad. So here's what you do next. See if you can get on board and bring your smartphone with you so you have actual sharp evidence of this. That would be really good. Until then, you swearing that you have seen this is not useful to anyone other than the show that happens in Congress. That's the public service message brought to you by the James Webb Space Telescope. So let's get this party started. We're going to find out what happened in the last couple of years. By the way, I think this is like my 4th time here. Who here is the first time coming to see me? Welcome. Welcome. Okay. So you had no idea what to expect either. You just came. You're just like, let's go.
It's Thursday, dude.
Did anyone here see the recent Mean Girls movie? I get a shout out in that movie. The Mean Girls, the main character is, she's smarter than everybody else, and she knows, she likes math and science. And one weekend, the parents were going to take her away to go see an event. But I forgot she was sick or something, but she stayed home and then threw a party while the parents were gone. But in the original story, they were going to see the performing group Ladysmith Black Mambazo, which is a South African group that sings and dances, brought to American attention by Paul Simon. You know the song Diamonds on the Soles of Her Shoes? That song has Ladysmith Black Mambazo. Anyway, so the line originally was, she said, bye, I don't think I can go. I said, but you love Ladysmith Black Mambazo so much. I said, no, we can't. Okay, so for the musical, which happened 10 years later, they changed that lyric. They changed that. And so it says, oh, but honey, but these are tickets to see Neil deGrasse Tyson. And we know you love him. So that was just a name check in the film. So you were here now in that situation that they were describing. Okay? You get to see the film. So here it is. If you didn't know, oh thank you, the three of you here. As of this minute, an SUV-sized rover and helicopter are exploring Mars. All these countries are launch capable, all on their own, and plus there's collaboration among them as well. And with active probes sent to the Sun, Mercury, Venus, the Moon, asteroids, comets, Jupiter, and the Kuiper Belt, which is where Pluto lives. Pluto is a Kuiper Belt, icy, dirty ice ball, okay? As of last week, we have 5,569 exoplanets. We're witnessing the birth of private space enterprise. Gravitational waves are washing over us from black holes, and there's a killer asteroid headed our way. If we have time, I'll get to that. Here's this new telescope I want to tell you about. We have a poetic reference to a telescope that's new, where you get your first data. It's called First Light. Right, beautiful. Beautiful, First Light. Here's what it looks like, large synoptic survey telescope. You want to get a sense of its size. There's like a human being here and a car's. All of this is data processing, heavily infused with AI. There's no way we could possibly get through the data that this new telescope is obtaining. And what kind of data is it getting? So it's ground-based, so to 8 meters across. It will catalog 20 billion galaxies, 17 billion stars. It will catalog 90% of the hazardous asteroids that are more than 140 meters. And it's going to map dark matter, dark energy. But what's more important about it, it'll be the first ever movie of the universe. So think about it. When the astronomer goes to the telescope, you take some pictures, then you go home. Suppose that thing you took a picture of changed 4 hours later. You wouldn't know. Suppose you went every night and it looked the same, but suppose in between it did something different on a one-day scale. You would never know it. So this is our first attempt to see things that change in the universe. And when you see things that change, you're going to find asteroids that are moving across the field of view. And the camera is the largest ever in the world. 3.2 gigapixels, that's the size of the camera. Oh yeah. And LSST, that has too many, it's Large Synoptic Survey Telescope, we hate that. So we named it after one of our finest, Vera Rubin, deceased a few years back, but she was a pioneer in the study of dark matter. And this telescope is going to help us understand dark matter. So here's what's interesting. Time sampling of data. You take one picture and go home. When you take repeated pictures, you have to watch out because you can be fooled. Because if you time sample exactly in a moment where the thing is repeating itself, you'll think the thing isn't changing. And if you, and it can make things that look like they're going backwards or forward. Ever see the wagon wheel effect in movies where the wagon wheel looks like it's going backwards, but clearly it's not? Because the frame rate of the cinema doesn't match the movement of the spokes of the wheel, and it can delude you into thinking one thing is happening when it's not. So here's an example that's very clear. This is a stroboscopic views of just drops of water. They look like they're suspended. You put a glass there, a cup there, and it fills. So if you were an alien coming here taking images of this, you would think, oh, what have they done on Earth? Oh my gosh. These stationary drops of water managed to fill a cup that sits below it. Your conclusions would be wrong. Okay? Here's a security cam looking out to the driveway. Okay? And check this out. Again, if this is your data, see, think about it. When we look in the universe, we don't know what it's supposed to be. We only know what the data tell us. And if this were our data, we'd say, oh, there's a new kind, oh, stop. There's a new kind of bird that just floats. And we'd be trying to figure this out, inventing laws of physics to account for it. Now you all know what helicopters look like, okay? And that's what they do. All right, that's a helicopter. All right, we good. So now, this is also a helicopter, except if you've never seen a helicopter, you'd think this is just how they fly. Because your data is telling you this. Oh! Space alien technology that we don't know yet. Right. So the LSST, the Vera Rubin telescope, will obtain data on timescales that will prevent this from happening to us. So that we'll have a more honest and reflective representation of the actual universe. Let's keep going. Satellites and their orbital debris. Ooh. Okay. This is going to be a time lapse. When was the first satellite? Old timers. 1957. What day? Oh, Tuesday. Oh, that's that was good. That was good right here. That's good. By the way, Tuesday is funnier than Monday. When did when are we going to repay for the hamburgers? It was next Tuesday. It's just Tuesday. What that is. That was a character in the cartoon Popeye. Anyone? Oh, Wimpy was, thank you. Oh, who was Bumpy? It was Wimpy, right. Wimpy likes hamburgers. Everyone over 60 knows what I'm talking about. I'm an old timer, just to be clear. I'm an old man. My hair is actually half gray, but I tint it. Because the gray is coming in these mangy patches. And it looks like I have like a skin disease or something. So I'm gonna wait till it's more uniformly gray. Then it'll come out like Morgan Freeman, gray afro. Okay? But when I talk to old timers, I'm talking about myself as well, and other gray-haired folks out there. You all know Popeye. Anyhow, so Sputnik launched October 4th. That would have been a Tuesday. I don't know. So this is an animation of satellites year by year, and this might be small for the back row, but that date will proceed as we watch what Earth looks like. Here it goes. 1970. 1980. 1990. 2000. 2010. 2020. Okay, now you know why the aliens don't come to visit us. They said, what the hell are you guys doing? It's a big mess. And if you want to see the data on it, what do we have here? This is the accounting of the debris, according to NASA. By the way, everything here is debris that's not even a satellite. It's debris moving at 17,000 miles an hour that could bore a hole through you if you happen to get in its way. 28,000 pieces of debris, larger than a softball, are moving around low Earth orbit at 17,000 miles an hour. 500,000 pieces the size of a marble, 100 million the size of a pea, and they're all traveling 5 miles per second. Debris, that's not even what was shown in that animation. This is on top of what's in the animation. This is rocket parts that fell off, paint chips, booster parts, all of this. It's the trash heap of our modern spacefaring civilization. This, you can actually find this online. This is all the debris that NASA tracks, and Earth is down in the middle. That outer ring is a geosynchronous orbit, about 23,000 miles up. And you just take a look at that. This is just embarrassing. So the future of astronomy might be we just put telescopes on the moon, forget the Earth, you know? Or like James Webb, just put it out in space. We don't have to deal with that. So this is ongoing, and Elon Musk is one of the largest contributors to satellite pollution. When he puts up his Starlink satellites, there's like dozens at a time, and they all get deployed. And you might have noticed, and I didn't point it out, I'm sorry, many of the satellites in that time lapse were independent, but others were actually following a line with each other. And those are the sequence of satellites. Oh, by the way, he launches from California, and if you launch at twilight, then you see this stream of lights coming by. So those are UFOs. Okay? You know why they're UFOs? Because the people who see them don't know what they're looking at. That's what the U stands for. But to me, they're IFOs. Identified flying objects. Okay? That's how that unfolds. Let's keep going. There was a fireball on Jupiter. That was cool. It just happened last. Oh, by the way, that's the 60th anniversary day of what? Pluto, just we're done with Pluto here. The 60th anniversary of the March on Washington and Martin Luther King's speech. I haven't done that. So Jupiter clearly knew about that and wanted to celebrate it. So this is an amateur astronomer, and so here it is. Check it out. It's just a little thing, but it's kind of we got it. It's a meteor striking Jupiter, exploding in Jupiter's atmosphere. It's just a simple little thing. Here it comes. Isn't that cool? It's on repeat a couple of times. There it is. Yeah. That's it. That's the whole story. That happened last year. You don't always see a fireball hitting another planet. Earth plows through several hundred tons of meteors a day. And most of that you will notice as shooting stars. Oh, that's beautiful. Actually, no, we're getting slammed. Just, if those are big enough, then we go extinct. See, that's how that works. What's the latest on the moon? We're headed back to the moon with what? Artemis. Artemis, yes. Now, NASA was sort of early woke in this regard. Is that word outlawed in Florida yet? I think we're close to it, I think. Yeah, okay. So Artemis is the twin sister of Apollo in Greek legend. And so that's sort of a woke thing. And of course this next mission will more accurately represent the demographics of the United States, unlike the entire 1960s era astronauts. Okay? I'm old enough to remember all that. People say, oh, you want to do astrophysics? I said, yes. Oh, is it because you want to be an astronaut? I say, well, they clearly don't want me to be an astronaut. So no, I'm not aligning my life's ambitions to someplace where I am unwelcome. Plus, the universe is way bigger than just the Earth-Moon system. And that's what I really cared about. Let's get an update on Artemis. So there's 3 missions that are planned. Artemis 1 is already flown. That was a ship that went to the moon, orbited, and came back, had nobody on it. Uncrewed. That's the updated version of unmanned. See? NASA, I'm telling you, NASA's like doing its thing. Artemis 2 was supposed to launch this year. It got bumped to early next year. It's going to send a crew to the moon, but not land. They're going to go orbit and come back, be gone 10 days. Artemis 3 is going to spend a month on the moon, walking around, and they're going to the South Pole. Now, how big is the spacecraft? Okay, that's how big it is. Okay, no, you have no idea what that is. That could be a model sitting on my desk. So we need some, for comparison, okay? So, just for comparison, but no, that's still not the correct comparison. This is. Okay, that's how big it is. And it's got the boosters on the side, which is a new emergent way we've come to understand how to best send things into space. Hardly any rockets don't have boosters anymore. In the old days, we hadn't figured that out quite yet. So, all of this is fuel, and we're the astronauts in the upper bitty section. Okay? So that's the exploded view. Bad word to use with rockets. Expanded view. Expanded view. And where are the astronauts? They all never be right there. That's where they're going to be. Everything. So a rocket is a controlled bomb. Okay? Just so you understand. You know why? Think it through. The rocket equation, which was discovered 100-something years ago by Russians, by the way. Here's the rocket equation. Right? Stay with me. If I want to put a pound payload into orbit, and that takes 1 pound of rocket fuel, okay, I can just launch it into orbit. Are we together? Okay? It takes 1 pound of rocket fuel to put 1 pound into orbit. Suppose I want to put 2 pounds into orbit. You might say I need 2 pounds of rocket fuel. But no, because that other pound of rocket fuel weighs a pound. So I need a pound of rocket fuel for the thing I want to put into orbit. I need a pound of rocket fuel for the rocket fuel I haven't burned yet, and I need a pound of rocket fuel for the other payload that first piece of the first pound of rocket fuel was going to put. So I go from 1 pound of rocket fuel to 1, 2, 3, 4 pounds of rocket fuel to the next step. And you keep this up, it rapidly runs away from you. And you get a huge rocket to put a little bitty thing on the moon. That's the rocket equation. You wouldn't need this if you had filling stations in space. Okay. Until we have that, if you were to drive across the country and there were no filling stations, you'd have to have a huge gas tank. And half the energy of your gas tank would just be to move the weight of the gas that's yet to have been burned. So that's how this works. It's a fascinating, we're crippled by it, really, the rocket equation. Let's keep going. Rocket launches never get old. Here's an Artemis launch. Here it goes. Things I want you to notice are the main tank, that's the middle tank. It has liquid hydrogen and liquid oxygen. And the hydrogen tank is twice as big as the oxygen tank. Twice as big. Twice as much hydrogen as oxygen. When it puts the hydrogen and oxygen together, it makes water, H2O, and that is an exothermic reaction. It releases energy. So the plume and the exhaust from the main tank is water. Okay, now the solid rocket boosters, they have other chemicals in them, but you can throttle the one in the middle. You can say lower it, increase it. Is it time? Okay, they will start the main engine, and then they ignite the boosters, and when you ignite the boosters, it's gone. It just takes off. Okay, so you're gonna watch that happen. The countdown goes to when they ignite the solid rocket boosters, not to when they ignite the main engine. So watch for that. Second, it's on a launch pad and there's all this energy coming out the bottom. There's a huge swimming pool directly below the nozzles. And right before they ignite the main engines, they dump a gazillion gallons of water into this, that's a precise amount, into this pool, and the vibrations get absorbed by the water. Otherwise, the vibrations would bounce back up and destroy the craft. So it's a water acoustic absorbing system. Very simple and easy. And because there's hydrogen involved here, hydrogen is what? Explosive, thank you. It's so explosive, you don't want to ignite your engines and have a pocket of hydrogen that had leaked out. Then the thing blows up and then you don't launch. So, just before they ignite, they send sparks into that zone. And each spark, if there's any hydrogen, will eat up the hydrogen in a controlled way. All this is going on and you're going to watch it. Here it is.
Counting down to liftoff of Orion on its maiden voyage to the moon. Launch team can no longer cycle the count. Silencer pressure water now flowing under the ML. And here we go.
Sparks.
10. Hydrogen burn-off igniters initiated. 7, 6, 5. 4
main engine
start.
Ignites.
3, 2, 1. Boosters ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
All 4 RS-25 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour. Carrying good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis 1. First milestone will be for the vehicle to pass through max Q at about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket. Now traveling 607 miles per hour. You're looking at 8.8 million pounds of maximum thrust quiet here in the loops of mission control. Full course engines passed. The next major milestone will be for the solid rocket boosters to cut off and jettison in about 2 minutes and 11 seconds into the flight, so about 30 seconds from now. Again, quiet here in Mission Control Houston as teams continue monitoring the flight of Artemis 1.
There are people who live and walk among us who say, I don't trust science. What do scientists know? I have my YouTube video, and that's where I get my science. The scientists, they don't know anything. They want me to take a vaccine, but what do they know? Scientists. I don't trust science. What do people think we do? Our whole job is to figure stuff out. That's what we do, that's all we do. And I'm putting, there's a rocket on the moon. All right. Sorry, that just came out of me there. They're headed for the South Pole. What makes the South Pole interesting and a destination is, if you know about Earth, like the farther away you are from the equator, the lower the arc is of the sun during the day. You're here in Florida, so the sun gets pretty high, but for everybody else, the sun doesn't get that high. It gets lower and lower. You go to the Arctic Circle, it can get as low enough so that it never rises. Okay. If you go near the poles, on the moon, there are craters that have crater walls. There are craters where the sun never gets high enough to put light at the base of the crater. It is literally a place on the moon where the sun don't shine. It just occurred to me. So how old are you? Yeah, how old are you? You're 10? Okay. So it's a grown-up expression when we say, where the sun don't shine. Okay? Yeah, so I'll explain to you, because we're just grown-ups here. I'll explain to you, okay? If someone says, put this where the sun don't shine, they mean like put it in your butt. Nobody walks around with their butt out, you know? So, just to catch you up on vernacular. Yes, okay. Thanks for coming. Right, that book, The Young People Astronomy in a Hurry, it's for tweens, age 8 to 12. You're a tween, in case you didn't know that. Okay. So when comets, the moon's been hit before. When comets and asteroids strike, you know, stuff gets strewn everywhere. When a comet hits, which is mostly made of water, any of the water molecules that land in exposed areas will evaporate away. But if any of that water molecules lands in the bottom of that crater, it is there forever. It is called a cold trap. It's like nearly 300 degrees below zero Fahrenheit. That water is not budging, and it's been accumulating for billions of years. So, if you're gonna go to the moon, go to where there might be water. And if there's water there, you can separate the hydrogen and the oxygen, and then you have what? Have what? Thank you! I thought we went over this. Let's try it again. You can separate the hydrogen and the oxygen, and then you have rocket fuel, okay? The moon then becomes a filling station. You think I just say stuff randomly throughout the talk? It's nothing to do with anything that follows? No, there's a whole plan here, okay? So everybody's headed for the South Pole. Here's a is obviously an artist's representation. They notice the shadows are long because the sun is not very high. And so they're digging for water. Now, it's not just puddles of water. You can't go ice skating. You have to mine the water. It's water molecules mixed in with the other ingredients on the Earth's on the moon's surface. You know who was the first to land softly on the South Pole? The Indian Space Research Organization. India soft landed on the moon first. Yes. India was one of the flags on that first slide. So this was the headline. India becomes the 4th country to land successfully, which means softly. A week earlier, a Russian craft headed for the South Pole crashed. Okay? So crash technically counts as a landing. So success, but to me that was not the story. The real story was that they were the first to soft land near the South Pole. So, other countries are involved in this, and I'm well known in India because they always ask me to comment on their space achievements, which is fine. Because they have very severe poverty there, and we have poverty, and we had it in the 60s when we went to the moon, so I have responses for that. But I saw some ugly things that I thought only Americans were capable of. Okay? So you know in India there's a tension between the majority Hindus and the Muslims. It's like a 4th Muslim in the country, and the leader is Hindu, and he has some sort of Trump in him in the sense that he can gain political favors, he can gain political influence by finding an enemy to say they are your problems, and then the majority bands together. Okay, so that's going on. There's a little bit going on there, and then now do you know the Pakistani flag? It has the crescent moon and the star, just symbol of Islam. Okay, Pakistan is primarily Muslim. All right, and they've been at each other's throats ever since, 1947, was it, old timers? When was Pakistan formed? Anyhow, go watch the movie Gandhi, you'll get some of the history of that. Anyhow, they were dancing in the streets when they landed here, and then they decided to stick it to Pakistan. And there was a slogan where they said, India, oh, by the way, they put a rover on the moon with this lander. And in the treads of the rover is an imprint of the Indian flag. First, that's the kind of thing Americans would do. You know that, okay? Okay, no, sorry. That's the kind of thing America would do. And here's another one. They were just trying to stick it to Pakistan. He says, in India, we have our flag on the moon, but Pakistan has the moon on their flag. It's evil and funny at the same time, right? It's just, but anyhow, it's I met Prime Minister Modi this past summer when he came through New York. I don't have time to detail that for you, but dig it up online and you can see some photos and part of what we talked about. I tried to put the message of inclusiveness in his worldview. And I gifted him a book I wrote on space. And I said to Prime Minister Modi, because he has a lot of space ambitions, I said, for whom the sky is not the limit. I said that. And then the next day he's in Washington with Biden and they have a press conference. And then the press asks, India, what's in store for your future? And he says, for us, the sky is not the limit. So I moved the needle just a little bit there, just to help out. Anyway, I don't have time to do the whole story, we gotta keep going. The solar cycle. Maybe you didn't know the sun goes through cycles. And it's very simple. The cycle is how many sunspots it has. And And that number goes up and down. And it goes to a maximum, then it goes to a minimum, and that cycle averages about 11 years. And we started counting the cycles like 300 years ago, and we're in this cycle right now. And the prediction is the red line, and the blue line is the actual center of what's going on. So it's getting high a little sooner than we expected, but nothing out of the range of what we've been experiencing. And in fact, the sun has been a little quiet compared to 10, 20, 30, 50 years ago. But that doesn't stop journalists from trying to freak you out. Okay? By the way, when the sunspot numbers go up, so do explosions on the sun, flares, so the sun gets active, and we are monitoring the sun better now than ever before. So now we know what it's doing, whereas before we had no clue. Okay? So, solar storm warning. As the sun blasts Earth, this is the kind of headlines that come out. All right? Our sun has entered a new cycle, the current one, and it could be one of the strongest ever recorded. This is clickbait. Well, let's keep reading this article. Let's see what it says. The sun may be in for a busy time according to new predictions. The next maximum could be one of the strongest we've seen. This is in direct contradiction to the official solar weather forecast from NASA. You're a journalist and you write this story?
Her last name's Star.
Yeah.
Yeah. I should pop her a note just to find out where she's coming from. This is a close-up of the sun's surface. Take a look. It's a roiling, boiling. What happens is you have pockets of the sun that are hot and they rise up, as anything that boils does. But as it rises up, something has to descend. That's what the boiling sequence is. And so this is a specially designed solar telescope looking very close into the surface. This is on a loop, and it's mesmerizing, isn't it? Just kind of stare at it. The surface of the sun. Well, let's keep looking to see what people want you to click on. Solar maximum will arrive sooner and last longer than previously expected. It's a significant change. This is an article from a couple of months ago. They're trying to scare you. And I'm going to tell you, if the world is going to end, I'll tell you about it, for sure. They're looking for ways to get you to click on their articles. But the storms are quite significant. So let's take a look, okay? Now, how big is Earth compared to all this? You might wonder. Yeah. Okay. So, the sun is badass, all right? Don't mess with the sun. But people see this and they freak out and they write an article, but the sun does this all the time. So, we have a craft that went near the sun closer than any other craft has before. And it's called the Parker Solar Probe, a mission to touch the sun. Which is a lie, but it's poetic. If it touched the sun, that would be the end of the mission. Okay? The mission to crash into the sun would be more accurate. But let's see what it's done. What do we have here? So on September 27th, that probe by the sun has very strong gravity. You come near it, you accelerate. It went 394,736 miles per hour, 110 miles per second. That's fast. But it's still hopelessly slow compared with the speed of light. 0.06% the speed of light. But it got within 4.5 million miles of the sun, and so this enables us to measure solar activity as never before, with higher precision than ever before. And it made the news for a brief period of time. The fastest ever human-made object. This article was just in October of last year. So just so you know, we're going not only out to the outer solar system, but we're also trying to check out the sun. Trying to make sure it doesn't misbehave while we don't know it. And It also flew through one of those ejections. This is where they say it's touching the sun. What they should have said is solar probe where the sun touches it. Okay, that's really how this happened. And here's the data for it. So check this out. Ready? So, okay. So I'll show you. Okay, it'll be obvious. No, that wasn't it. That wasn't it. That's it. See that? So that was the flare that went across the craft, and this is the data that it's taking while that's happening. So we're monitoring the sun for your own safety. Okay? Let's keep going. Exoplanets. Ooh, love me some exoplanets. The first exoplanet was discovered in 1995. Before then, we knew of no planets outside of our solar system. Who here has been born since 1995? Raise your hand. You're 10 years old, you have been born since 95. You get to raise your hand. Yes, thank you. Okay. You were born in 2013. Cool. Is that allowed? Is that a real thing? Okay, raise your hand if you're born 1995 to today. Raise your hand. A few of you. Okay. All right, cool. Keep your hand up. I now declare you all Generation Exoplanet. Okay? You've only known life where we had exoplanets in the data set. These are different ways of discovering them, and here's the most common way that we use today. It's called a transit method, where you find a star system out there that you happen to be viewing edge on. You just wait around for the light of the host. You can't see the planet. It's too little and it's too dim. But if the planet passes in front of the host star, the light of the star dims and then comes back to normal. And if you see that repeat at very regular intervals, you have discovered a planet. And so this is a highly potent method for discovering them, and there was 1995, it was 0, and oh yeah. But I'm just science. What do scientists know? Science, they don't know anything about global warming. They're just lying to you. I don't want to believe them. Sorry. That comes out there. This business is highly collaborative. Here's someone who, this is the wide-angle search for planets. All of these countries are involved in this search. Discovering planets, the WASP is the acronym for the catalog. And so now I don't know why the United Kingdom flag is bigger than the other flags. I have to look into that. Just little things like that. Anyhow, it's highly collaborative. There's a telescope that's since been decommissioned, the Kepler telescope, that sort of birthed the transit method discovery, and that's been replaced now by TESS, Transiting Exoplanet Survey Telescope. It's active, ongoing now. This has gone out into space, and it is monitoring the light of millions of stars. I think it's millions. A big number of stars, looking for dips in its light. But not only that, the data can be so complex. Suppose 2 planets are crossing the sun instead of 1. Then the dipping is like, what is it doing? Okay? And so we put a deep neural network on it. It's our version of AI. And it has discovered planets all by itself, mined from the data that would otherwise confuse us. And so these are, inside the circles are planets in space that have been discovered by this method. And the James Webb Telescope has discovered rogue planets. These are planets that don't have a host star. How does that happen? We would learn in the era of computers, because I predate computers. That's how old I am. I'm telling you, I'm right. Don't be surprised one day I'm gray, okay? Once we would bring computers to the problem, okay, we noticed that the solar system probably started with dozens of planets. And there's a I don't want to call it a contest, but planets are jockeying for stable orbits, and not all orbits are stable. In fact, most orbits that you put into motion around a star, if there's other objects there, they're not stable, and they get ejected from the system, or they fall into the host star. We think there are more planets ejected from birthing star systems than there are successful orbits within them. The James Webb Telescope found, in fact, 500 rogue planets, and 40 of them were binary planets. So when we think of planets, we're so previously biased by it's got to be orbiting a star. Well, maybe not. And in fact, we could be home to trillions of worlds gone rogue. So an artist's impression of a free-floating planet, the artist has no idea what a free-floating planet is. And I don't know why they didn't show it completely frozen. They should just not have shown it. We don't know what these planets are. There's no light shining on them. We find them by other methods, okay? Something called gravitational lensing. But this is all current news. This is August 6th. That's another anniversary. What anniversary was that? Yeah, Hiroshima. If you saw Oppenheimer, yes. I actually Barbieheimer. You know what that is? I asked my 10-year-old, what happens if you Barbieheimer? If you Barbieheimer, what is that? Do you know what that is? Oh yeah, okay. So Oppenheimer, a film about war and bombs and nuclear energy, was released the same day as Barbie. You can't get two more opposite movies to exist in the universe than what happened on that day. So if you Barbieheimer, then you saw both movies on the same day. And that's what I did. So, I don't know why that would deserve applause, but I'll take it. And then I tweeted about that experience. So I had Oppenheimer tweets, and I had Barbie tweets, and then I had Barbieheimer tweets. So which one I'm going to tell you only one of the tweets. Which one of these three do you want to hear?
Barbenheimer.
Barbie, Barbieheimer, or Oppenheimer? Barbieheimer? Okay, here's a Barbieheimer tweet. In 1958, there were 111 nuclear tests on Earth's surface conducted by Russia, the United Kingdom, and the United States. That's the second highest of any year during the Cold War. In 1959, Barbie is introduced to the world, and the number of nuclear tests was 0. Okay, I got you. Okay, that one didn't go viral. Let me give you the viral one. This is just a Barbie tweet. Based on the elevation and orientation of the moon in Barbie land, and the fact that it rose and set over water, it requires that Barbie land exists between 20 degrees and 40 degrees north latitude. Okay? But I keep going. Because Barbie land has palm trees, it means it's probably between 20 degrees and 30 degrees latitude. If it is that, and the sun and moon rose and set over the water, it can only be the southern tip of Florida or the Florida Keys. People lost their minds on this, okay? astrophysicist knows where Barbie Land is on the map. But, now, there was an issue. Someone commented, but Dr. Tyson, in the background there were mountains. And then I double checked the average elevation of the Florida Keys. It's 5 feet above sea level. So yeah, do you go with the mountains or do you go with the moon? So I went with the moon. Otherwise, you can't put it anywhere. Okay, it would just be an imaginary place called Barbie Land. That's exactly what it is. But one thing is very clear, not only not in the Florida Keys, but nowhere in Florida do you have mountains, okay? You might have a few hills, sure, but you ain't got mountains. That's why you are the first to go as the sea level rises. Know this. I don't believe in climate change. What scientists know? They don't know anything. Biggest known star in the galaxy. This is cool. 1,700 times larger than the sun's radius. It has a name, Scuti. The stars within constellations are lettered, first with the Greek alphabet, and then with the Roman alphabet, and then we double up as the numbers get high. And then the constellation, we give the genitive form of the constellation. So this is the constellation Scutum, and the genitive form is Scuti. So Scuti. It's a red hypergiant. And here's a photo of it. It's just a dot in the sky, brighter than surrounding. But you want to know how big it is? Here it is. So let's quantify this. Wait, I have to check a calculation. No, I'm serious. I thought I wrote it down and I didn't, so I have to recalculate it. Yeah, that's it. Okay. Carry the 2. Oh, we've got to carry the 2, don't you? Okay. All right. So, if the sun were hollow, you saw from the earlier image, if the sun were hollow, you could pour 1,000,000 Earths into its volume and still have room left over. If UV Scuti was hollow, you could pour 5 billion suns into it. Oh yeah. Universe. Let's keep going. The first ever image of a black hole. Oh my gosh. Okay, here it is right here. I want you to notice the detail, especially over here, it's in full color. You have to see what the black hole does to the fabric of space-time in its vicinity. Black holes is a throat through and what happens is, because space-time is curved, light from behind the black hole, its trajectory gets bent. It gets bent around the black hole, and it makes a ring of light. Here's an actual, authentic computer simulation of that phenomenon. And this is a black hole passing in front of the Milky Way, done by physics students at the University of Seoul in Korea. So here it is. So when you see a black hole in space, that's the music you hear. All right, so what happened is we have something called the Event Horizon Telescope. The event horizon is the region of space around a black hole where you cross through it, you do not come back out. It's a great poetic name for such a deadly place. in the universe. Well, in 1919, that telescope, which is a consortium of radio telescopes around the world, who pooled their data to get the resolution necessary to see a black hole in a galaxy, 1.6 million light years away. It's a galaxy in another cluster of galaxies, in the Virgo cluster of galaxies. Not a star cluster, cluster of galaxies. We are a galaxy. Go over there, there are other galaxies. Look in the middle, we find a supermassive black hole, and this was headline image right there. The Event Horizon Telescope. Then they got AI and applied it to the data and improved the resolution, and we get that. And that was published just this past year. And so those are the hot spots you get as starlight from far beyond it wraps around and you see the circle of light. This collaboration is over many countries and many telescopes. And they're all radio telescopes. They're sensitive to radio waves and microwaves. And so they're all over. And the affiliated institutions, let me just say that we're all human, and we live here on Earth's surface. Yet, and we see Earth from space, it's like clouds, and land, oceans, beautiful. Then you get close and you find out we've carved up the land. And if you live on one side of a line versus another, that in some parts of the world is justification for committing violence. How odd that would look to a visiting alien. They say, aren't they the same species? Yeah. So what's up? Oh, well, they worship this god and they worship that god, or no gods, or they sleep with this person instead of that person, or their skin reflects light differently from the others, and so that's why they're killing each other. The alien would rush home and report back that there's no sign of intelligent life. I say this because this perspective, this cosmic perspective of Earth without borders, looking completely unlike the schoolroom globe we grew up with. You know, when I was younger, I said, oh, this is how we learn what the countries are. And then in my older cynicism, I said, no, that's how we learn where our enemies are. We are indoctrinated to think about other human beings as other. From the earliest understanding of a globe, that's how we're thinking about it. Rather than thinking of Earth as a planet and later on say, oh, by the way, we carved it up just because it's easier that way, or the cultures are different. Then that becomes an after the fact thing rather than a fundamental reason for why you're going to have an attitude about somebody who you never met. And so, now, why am I saying all this? Maybe what we have to do is take all the world leaders and send them to the moon. No, I don't need to get rid of them. I mean, send them so they look at Earth. I didn't mean. So they look at Earth and say, wow, oh my gosh. Because countries choose sides. And they argue and they don't get along. But you know who gets along? Scientists. The value of pi does not change going through passport control. It is the same. Scientists know how to collaborate. That's how we roll. These are the collaborating institutions of the Event Horizon Telescope. The universities, institutions, some cooperating governments, science. Because in part, we speak the same language. The math is the same, the physics is the same. We have things in common that matter more than what we have that are different. So we treat each other with respect. By the way, after that photo came out of the black hole, I had to tweet something about that, so I did. Okay, here it is, back row, I got you here. Okay, here we go. Scientists, we've produced the first ever image of a supermassive black hole, that's the correct distance, 55 million light years away. And the public says, ooh. Scientists, we've concluded that humans are catastrophically warming Earth. Response, that conflicts with what I want to be true, so therefore it must be false. Welcome to my world. It's the latest on the Big Bang. I did this experiment. If you type Big Bang into a Google search, you get K-pop. Very popular band called the Big Bang. All right, so that didn't work, okay? How about, let's try Big Bang Theory. No, that didn't work either. Okay. Realize this was the most popular sitcom like ever. And it was science. I'm imagining earlier attempts to sell this to a network. And you go into the room, they say, I have an idea. It's going to be a comedy with scientists and their PhDs, and they work in a university, and they're going to tell geeky jokes, and you'll only understand some of them. Wouldn't that be great? They say, no, we need another cop drama. We need another... And finally, CBS agrees, and there's all this low-hanging science humor that was plucked for this. And in the end, they were making, each cast member was making $1 million per episode. That's how successful this series was. And I know they're making a lot of money because I appeared in 2 episodes. Now watch, I did the math, okay? I get a residual check for appearing in those 2 episodes. All right, how much is the check? It depends, but occasionally the check is like $300. I'm not gonna change my lifestyle on that, but I was on for 2 minutes in 1 episode. They're on every day and every episode, okay? I just multiply that up, and I said, damn, some rich folks right there. Okay, so the Big Bang that's the Big Bang. Can we improve on this? I know, we have to say, the Big Bang. And we say, the Big Bang, now we, oops, but okay. Now, some people don't like the Big Bang. Why? Because it conflicts with what they need to be true. And apparently, God is upset about it as well. So this is where the collection plate money is going, okay? Right? It's supposed money to get it. Isn't that much money? I mean, I'm impressed that they care. So how does the Big Bang work? All right, so the universe was smaller and hotter in the past. These are basic tenets of the Big Bang. Not tenets, realities of what we got going here. Oh, I have to hit the button. Did you get it? Okay, here we go. The universe was once the size of an atomic nucleus. Okay. In my book, Astrophysics for People in a Hurry, I open with a sentence. Do you know what that sentence is? Thank you for that answer. Yeah, attitude. No, I don't know what that sentence was. Well, if you bought the book, then you would know. My opening sentence is, the universe is under no obligation to make sense to you. Say, okay. The universe was once the size of an atomic nucleus. Let's keep going. Began in an explosion. experienced early rapid expansion, and it's about 13.8 billion years old. Here's a diagram of all that. Here's the beginning right here. This rapid expansion. This is a timeline of the universe. It's a space-time diagram of the universe. And we have the rapid expansion at the beginning, and this is today over here on the far right. At the very beginning, the universe was so hot it could not make stable matter. So it was a matter-energy soup. Then we cooled down enough that we could start to assemble atoms that could then come together and maybe make stars. But until that happened, there were no stars. So there's a period back there that we call the Dark Ages, where the universe is still trying to cool and figure out what it's going to do with its materials. Then it figures it out, and then we make stars and galaxies. First stars about 400 million years after the Big Bang. The Dark Ages, a very well understood part of our cosmic history. The James Webb Space Telescope, while it can see nearby gas clouds, was exquisitely designed to observe the formation of the first galaxies. In what way? Those galaxies give off copious amounts of ultraviolet light, and the James Webb Space Telescope detects infrared light. So how are you going to detect ultraviolet if your telescope is designed for infrared? Because over that time, the universe has expanded, stretched the ultraviolet light so that today that light arrives here as infrared. We pre-designed the telescope to accommodate the known expansion rate of the universe, so to take us right back to the beginning of star time. Okay, so it did that. And what happens, okay, in those dark ages, what happens? It found full up developed red-blooded galaxies in the dark ages. We're all scratching our heads. Do we understand, do we even believe we understand galaxies? It's doing exactly what it was told to do. Show us the early universe. And it's doing that, and it's confounding our prior understandings of it. And of course, that made good headlines. This is just a year ago, just discovered the impossible. How giant baby galaxies shaping up our understanding of the early universe. And the way these are written, it's like, oh my gosh, what are we gonna do? Rather than the telescope did what it was designed to do. Gives us more information, we'll make more refinements on that understanding. But it made a lot of headlines. Newfound galaxy, this is a little more tempered. Oldest ever seen. We know that they must have formed shockingly fast, thanks to the results of the James Webb Space Telescope. Again, that's Scientific American. This is physics.org, which should have been a little more tempered in this. Oh, by the way, just how the physicist views the world. You know, physics, earth, space, chemistry, biology, other sciences. Other sciences. They're wowing astronomy. See, they're not depressing us, they're wowing us. We're saying, oh my gosh, what are these? Let's keep thinking about it. So, watch that space. We still don't have it resolved. We still don't know. Because this is new information. That's the whole point of tonight's talk. This stuff that just happened. This just in. Okay. And on the subject of this just in, yeah, we gotta go there. Did you catch that news story when it hit? Okay, while our people were testifying in Congress, swearing they had aliens in a locked box. Oh, they used a term. You remember a term they used? Non-human biologics. Did you hear this term? The non-human biologics locked in a box in the back room. Okay. let's look at the tree of life. 30 million species. If you remove humans from that tree of life, everything else is a non-human biologic. So as far as I was concerned, he had like a branch of an oak tree in his room. That would be non-human biologics. So everyone said, oh, that must be aliens, but that's not what he said. Right? I'm listening to what he said. Anyhow, he didn't show. So I tweeted. I said, this is a start. What you really got to do is bring the aliens out so we can see it. So you can share tissue samples with labs to verify what's going on. That's what I told them. And within weeks of that, this happened. Okay, every line here is just what? Okay, Peruvian, 1,000-year-old, mummified aliens displayed in Mexican Congress. That's a lot going on there, okay? Here's Mexican Congress, here they are, okay? They got Congress, we you know, Congress, and they rolled them out. Here they go, the aliens. You know, I don't know Spanish, but I'm thinking, cuerpos no humanos. I think I figured that one out. Native Spanish speakers here, bodies non-human or something? How do I translate that? Non-human bodies, thank you. Cuerpos is that a dead body or an alive body or just a body? Just a body, okay. I forgot I'm in Florida. Many more people know Spanish than just the person in front of me. So everyone participated in those answers. So there it is. And they released photos of the aliens with a little bit of dirt on them. And then what was kind of weird for me was they have 3 fingers. So maybe that hand of God is their God. Well, okay. The people who presented this swear that these are real. Where did they get them? They got them in the Nazca Plains of Peru. Widely believed to be a place where aliens come to visit in the ancient alien hypothesis. Oh, by the way, they took x-rays of, there are 2 of them. There are 3 pictures here, but there's only 2 of them. They took x-rays and they found in one of them eggs. Someone here says, stop it. I'm just don't shoot the messenger here. I'm just saying. Wait a minute, weren't you in Tallahassee last night? I gave a whole other talk in Tallahassee last night. So you get, this is a 5-hour drive. That's right, okay, well thank you for showing up, okay. So they look humanoid because they have shoulders, torso, neck, eyes, nose, mouth, ears, head, fingers, eggs. So, do you know how x-rays work? Okay, so you sit in front of an x-ray machine and they put a photographic sensitive plate on the other side, and the image you see is in the negative, okay? And so the lighter areas are places where the x-rays do not penetrate. So that's where you see the bones and other structures. So we see a rib cage and bones, and we see eggs that the x-rays did not penetrate at all, which means these eggs are made of lead. Or some heavy metal. Okay, just Putting it out there. Meanwhile, Peru does not know how the non-human corpses ended up in Mexico. How did that happen? All right. I was on Colbert. I didn't say that to get an applause. I'm just giving you time and place for. I'm there, and they just rolled out the Mexican aliens, and I said, that's what we should be doing. If we have aliens, put them on display like they did in Mexico. That's what they should be doing. So I applauded this in Mexico. Oh, by the way, let me just go back for a moment because what I'm about to show you is just really weird, but where was it? Okay. Life on Earth is highly diverse, taxonomically diverse. The only thing on Earth that has faces are vertebrates. Faces like what you see here. Other life forms don't have faces. Oak trees don't have faces. Worms don't have faces. Octopus that has eyes but doesn't have a face, like a face? Like, no, so that's a very vertebrate thing. And vertebrates are a branch in the tree of life among countless other forms of life. Okay. The absence of ingenuity of people who want to claim they've met aliens manifests because the aliens always basically look human. They think this does not look human because it's got like elongated head and it's like he's smoking a cigar or something in his mouth. And I'm telling you, if you are an actual alien and you came and saw this, say, oh, it has two eyes like you do, it has eyebrows, nose, mouth, nostrils, ears, it's got a neck, shoulders, torso, fingers, hips, femur, calf, and toes, you'll say this is identically human. You say, I don't see the difference. Because so many other things look way different from us with whom we share DNA in common. So all I'm saying is, if you're going to come from another planet, and you have no DNA in common with us, you better at least look as different from us as we look from other life forms on Earth. We share 40% identical DNA to a banana. Look more different from us than we look from a banana. Then how do you get an alien on your hands? Okay? But maybe these are real. That's my pre-analysis. Maybe these are real. Okay? Maybe. After my Colbert appearance, which I mentioned not to get an applause, just to set up the next slide, I got email from Sorry, this is not strictly true. I got email from the person who presented the aliens in the Mexican Congress. Here it is. Okay, this is in October. That's not 2024, that's 2023. Sorry. Subject, the Nazca mummies. Dear Neil deGrasse, it is an honor to establish communication with you. My respect and admiration for your work. I saw the interviews on CNN and The Late Show where you expressed interest in continuing the investigation in relation to the Nazca mummies. Again, Nazca is a region of Peru, and these showed up in Mexico. Right. We want to express to you that we have the corpse that we've shown in Congress, and it's under legal protection in Mexico City. We want to share with you all the research and work we have made. It's our special interest to make alliance and continue this important research with you. If this is your interest, we extend cordial invitation for you to come to Mexico City with expenses paid with the cordiality you deserve. Sincerely, Martin Aquerica Ramos. Okay. The Nigerian prince. So, no, this is... So, okay. So I wrote back. I wrote back. Okay? I wrote back. Okay? Thank you, Senor Ramos, for that kind invitation to visit Mexico City and personally inspect the alien bodies. I claim no special expertise in the analysis of biological tissue. That's the work of biologists. There's an extra A in there, I have fat thumbs. And ideally, biochemists. Your research needs to be written up, submitted for peer review, published in a research journal, and ultimately offer samples of your specimens for peer analysis, sharing biological tissue via multiple labs. That's how objective truths are established in science, not by sworn testimony or the impassioned plea of a single group of researchers. We do this for findings much less extraordinary than what you have presented. On that level, it's routine procedure. So it will never be about what I think. It's about the quality of the data and its verification. Best to you. Never heard back from him. Yeah, didn't hear back. Anyhow, but I'm going to see if he's still. I mean, so I don't want to discount something outright. I want to investigate it, right? It's intellectually lazy to reject it. As weird as those two aliens were with lead eggs, reptilian, humanoid, egg-laying, cigar-smoking. All right, let's keep going. How am I doing on time here? Ooh. Okay, I gotta speed up. I tell too many stories and they just... It's okay? I can tell, you allow me to do the stories? Asteroid defense. Okay, they're bad asteroids out there. Asteroids whose orbit crosses the orbit of the Earth. If it does that, it will eventually collide with Earth. You can run the math on it, the orbital mechanics. So do you know how many asteroids have orbits that cross the Earth? This takes a lot. Yes, thank you for that precise answer. Right here, here's a list. Okay, every box here is the phone number of an asteroid that will collide with Earth. So this is an old list actually, but that's just some of them. Let's keep going. There's that, and 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 okay. So, I don't want to be the laughing stock of the galaxy. To be a civilization that has a space program and doesn't know how to use it to protect our lives. That would just be bad. That'd be embarrassing. What happened to the humans? Yeah, they don't trust science. They don't trust science. Here's another one of those time lapses. So this is all the known near-Earth asteroids. These are the hazardous ones. Let's put this in context. This is the orbit of Jupiter out there. There's a big gap before you get to the inner planets. That's the asteroid belt. All the asteroids there are safely orbiting the sun away from the Earth. I have an asteroid named after me. And before I agreed to accept that honor, I said, does it cross Earth's orbit? No, it's safely in the asteroid belt. Because you don't want that to be the asteroid that takes out civilization. Asteroid Tyson headed straight for us. Some people can't shake Pluto. I gotta put this Pluto thing to bed because some of you are still upset by this. Do you know that there are 6 moons in the solar system bigger than Pluto? Mm-hmm. Yeah, but they don't tell you that if you're a Pluto lover. They don't want to upset you. Do you know our moon, which is one of those 6, has 5 times the mass of Pluto?
It doesn't matter.
Wait a minute, I ain't done with Pluto. Did you know that more than half of Pluto's volume is ice?
So,
Which means, if you brought Pluto to where Earth is right now, heat from the sun would evaporate that ice and it would grow a tail. That's no kind of behavior for a planet. Not only that, Pluto's orbit is so elongated, it crosses the orbit of another planet. I think I will never convince you. I'm sorry. That's the answer to everything, right? And fly. So let's look at, those are the known near-Earth asteroids 25 years ago. Oh, so this Jupiter, the asteroid belt, Mars, Earth is the white circle, and then you have Venus and then Mercury, and the Sun is just a little dot in the middle. The orbits are to scale, but the size of the Sun and the planets are not. Okay, so this is another timeline, so let's do this. So this is 1999, and I think we fast forward 10 years here, right? That's what we knew in 2009. Go back another, and there they are. Earth crossing asteroid. Now we're going to throw in the asteroid belt, and you'll see. So the solar system is basically a shooting gallery. Like Florida. Is that the like retort to everything? All right, so we tried to protect ourselves, and recently had this. This is like recent, this happened recently. The double asteroid redirect test, and that's the patch for it. What? Missions have patches, so they can put it on there. So NASA launched this mission, and the whole idea is to crash into an asteroid. That's the whole point of it, okay? And this is the best image they got of an asteroid before we visited it, okay? So this is a picture of an asteroid 20 million miles away that's just as fuzzy as the Navy image in our atmosphere of a UFO. All right. Does this one? No, because we went there and confirmed it's not a UFO. So here's the mission. So it's a double asteroid with a moonlet. So Didymos and Dimorphos. And Dimorphos is the moonlet, and that's the one we're going to slam into. And so we do that. So here comes the spacecraft. It slams into it, and it deploys an observing craft that flies by to observe the proceedings. That other craft was made by the Italians. We collaborate internationally here. And the idea is that you can measure a new orbit and test whether this method works. This would be a deflection method rather than a Bruce Willis method. It's America. I know we want to blow stuff up because we can, but in space, if you blow stuff up, you don't know where the pieces go. Whereas if you deflect it, you fully understand what's going on at all times. So here's the mission actually going in. That's the big one, and then the moon is on the side, and this is actual data as it comes in. And you see enough detail to know that that's a rock in space. There aren't aliens waving to you. That's the blood that came out of it. This was successful. It changed the asteroid's motion in space by how much? Let's see. The original orbital path was 11 hours, 55 minutes. It shortened the orbit by 32 minutes. And we would have counted it as a successful mission had it shortened it by only 73 seconds. So this is very hopeful that maybe one day we will be able to deflect an asteroid. Now let me just remind you of what this mission was. It was a spacecraft launched from Earth, a moving platform, to intersect an asteroid, a moving target. No, the asteroid's moonlet, orbiting that moving target. Then it hits the target, gets data on the target, and reports it back. I don't trust science. What do scientists know? I don't know. You don't know anything. I just watch YouTube. That's right. What else do we have? An OSIRIS-REx. This one, an asteroid sample return. Oh my gosh. Oh, what happened here? Okay, it was launched 9 years ago, and asteroid Bennu, that's the name of it. It had an encounter back in 2020, and this mission went to an asteroid, did a touch and go. It plunged in, kicked up some asteroid, grabbed it, stuffed it into a little capsule, and came back to Earth, okay? And so it came back to Earth on September 24th, just 4 months ago. And the asteroid will continue to visit the spacecraft will continue to visit another asteroid called Apophis. And it's going to have an encounter with that one in 2029. Here's that image. Here we go. Okay? Again, it's a touch and go. That is the surface of the asteroid Bennu. Now, how jaded we are that I show you an extremely high resolution image of an asteroid 50 million miles away. You say, oh, okay. Well, yeah, but that fuzzy thing are aliens visiting us. Yeah. In fact, I'm not happy with your response to that. Let's go back. Okay. So, in this next image, you're going to see the surface of asteroid Bennu. All right, check out this touch and go. This is just badass.
Oh, wow.
Oh, yeah. So it grabbed material, packed it into a capsule, came back to Earth, and just dropped it off. And kept going, and that capsule landed in the Utah desert. So now, let's just, not by accident, that's a Department of Defense test range, okay? So let's do the OSIRIS-REx dance the way we did for DART, okay? OSIRIS-REx was launched from Earth, a moving platform, to intersect an asteroid, a moving target, touch and go from that asteroid, grab material, stuff it into a capsule, come back to Earth, deploy the capsule on the rotating Earth so that it lands in the Utah desert, and then it keeps going to another asteroid. I don't trust science. Just don't know anything about anything. Okay, Bennu is actually an Earth-crossing asteroid. So, in fact, we can calculate the chances of it hitting Earth. It's 160 years from now, 1 in 2,700 chance of hitting Earth. And there are people in casinos who bet on much worse odds than that, thinking they're going to win. You say, oh, that's not so bad. But 160 years should be enough time to do something about that. Should be enough time. It's none of these, it's headed our way. Nothing. No, we see orbits, and it's when the orbits intersect. If you get it early enough, you just have to nudge it a little bit, and that little bit accumulates so that it can miss Earth entirely. That would be the goal. How big is Bennu? Here it goes. There's Bennu. I like that whistle. My favorite poster ever, asteroids. Nature's way of asking, how's that space program coming along? Oh yeah. My favorite poster ever. We're getting through that table of contents, aren't we? How about the Space Force? What's up with that? So it turns out a lot of people objected to the Space Force. I think primarily because it was that these people didn't like Donald Trump, and Donald Trump signed the Space Force into law. So if you don't like a leader, then you don't like anything they do. That's the cancel culture that we live in. You're not capable of saying, oh, this was okay, and they like that, but I don't like this. They gotta not like everything. So that's a curious state we're in right now. State of existence. State of Florida. Okay. This symbol is suspiciously like what? All right, there are people who said, oh, what is this escalation in space? This is bad. No, just chill for a minute, okay? Old timers might remember, and I'm not this old, but who's like the oldest person in this room? Anyone here over 90? Like, raise your hand. You got a 90-year-old somewhere? Oh! 87, so that's born. Who can do the math on that real quick? 87 puts you when? Oh, 1936. So when you were 11, until you were 11, the Air Force was a branch of the U.S. Army. The U.S. Army Air Force. And then you realize you're flying a plane that's different command and control than driving a tank. And you need to know aerodynamics, and the engineering is different. And so after the Second World War, 1947, they said, let us split the Air Force from the Army. No one today would question that move. It made complete sense. Okay? So, what happened until a couple of years ago? Air Force had something called Space Command. Yes, Air Force was into space. That's where the GPS satellites came from. The Air Force launched those, okay? But Space Command and Control is different from airplane command and control. And so it kind of made sense that we have a new theater of operations, space, that there was in 2021, the Space Force peeled off from the Air Force. This was done in a ceremony at the White House, and did I say anything about this, This is General Raymond, who was head of Space Command, who was the natural head of the Space Force when it was forged, and the question is, can General Raymond smile? That's the real question here. Because this should be a smiling moment, okay? So then I found other articles with him in it, and Because the Joint Chiefs of Staff now has a new chair. It's a new slot. There's there's the Army, the Air Force, the Navy. I think the Marines have representation in there, but the Marines are a branch of the Navy, and the Coast Guard, and now we have the Space Force. So does this man ever smile? And I interviewed him for my podcast, Star Talk, and he came to my office, and yes, he can smile. Give it up for the gentleman. Now, here's something I regret. I didn't think about this. It was like, I was just so excited. I had a 4-star general in my office. And I think you're not supposed to touch the general. Right? You just don't do that. You don't grab his chevrons and the thing. No. So, but yeah, I was just, okay. He does smile. Just a couple of minutes left. Jeez. Okay. There was an eclipse this past year. It was called an annular eclipse. Annular from Latin annulus, which means ring. That's an eclipse where the moon is not big enough to completely cover the sun. And so when it passes in front, it leaves a ring. And that was the path through North and South America, coming out into the South Atlantic there, out of Brazil. But when these are photographed, they can be quite striking. Here's an example. Very beautiful. It's an annular eclipse. The moon has different distances from us in its oval path around the Earth. So sometimes it's larger, sometimes it's smaller. We have an oval path around the sun. Sometimes it's larger and sometimes it's smaller. So if you have a small sun and a big moon, that's a long eclipse. It takes a longer time for the moon in its orbit around the Earth to pass in front of the sun. And if you have a small moon and a big sun, then you get one of those. So, this one we shared with South America, but coming up April 8th, there's an eclipse that's America's eclipse. America. April 8th, there it goes. America. Plus Mexico. And Mexico is, of course, in America. So, and Mexico has states. So, and they're united. Oh, yeah, okay, it touches Canada. All right, I guess so. Sorry about that. But Canada is also in the Americas. By the way, I've been through this. I don't have time for these stories. We're gonna run out of time. Yeah? You sure? You sure? Okay. I'm just gonna tell you this. I haven't. What's that? You have school tomorrow? No? Not anymore. Yeah. Yeah, that's fine. I promise you that in the last 2 hours you have learned more than you will ever learn. So, I've said America to be identically equal to the United States of America. I've used the term. But invariably, people from Central and South America say, we're America too. Okay? All right, but hang on. Don't start clapping yet. You don't know what I'm about to say. So I thought about this, and I said, all right, let me look at the currency of every single country in North, Central, and South America. In the United States, we are the only country that has the word America on our currency. And it's there multiple times. So if you feel so strongly about the word America, then put it on your damn currency, and then I'm okay with that. But until then, I'm going to say America. I did the research here, okay? Yes, of course it is named. By the way, America is named for Amerigo Vespucci, who was Italian. All right? So, anyhow, where was I? I didn't have time to tell you that story. Tampa, you're getting like 48% eclipse.
That's my.
Sorry, higher up there. No, wait a minute, no.
Yes.
Wait, hold on. Are we talking about the circle in the middle or the tip at the bottom? Oh, it's wrong. Oh, got it. Okay. Okay, this is software from a website called Time and Date. And you type in a city and it puts a marker there. And so I'm gonna have to check on that. So thank you for that. It could be a bug. Maybe it just thinks all Florida cities are just right there. Yeah. In Tampa, well, I'm gonna give you the number it gave me for Tampa, Florida. So maybe it's wrong, but if it's wrong, it's not that wrong because the eclipse completely misses you, okay? The totality of the eclipse. You're getting about a 50% coverage of the sun in most of Florida, okay? And so you're not gonna notice that. Just, you know how bright the sun is? When the moon has covered 99% of it, the remaining arc of sunlight is brighter than the light of 10,000 full moons. So if you have never, give me that whistle again. So if you have never been in a total eclipse, you've not been in an eclipse, okay? So this is how you test it. You ask someone, have you ever seen a total solar eclipse? And say, well, let me think. The answer is no. Well, I think no, the answer is no. You ever been in a total eclipse? Yeah, oh my gosh. Yeah, that's a yes. Okay. So you have to travel into that arc. It's the center line there that goes up, and of course, kissing Canada at the top. Yes. All right, I gotta land this plane. We're gonna do reflections on life. Because we're talking about recent news, okay? So, last November, I lost my mother. And 2 days before her 95th birthday, this picture was taken in my office when I was interviewing her for Mother's Day, which is an episode of my podcast. So I invite you to dig that up, just with Neil's mom. And what I'd like to do is read for you a portion of a chapter in this book, Cosmic Perspectives on Civilization. These are the chapter headers. Many of them are just totally controversial subjects that we argue about over Thanksgiving dinner. Law and order, body and mind, truth and beauty. So this is what all those subjects look like in this book when you're scientifically literate and you have a dose of a cosmic perspective. In the coda of this book, Life and Death, I want to read an excerpt from it for you. Can we take out the lights of the house and the stage? Is that possible? Yeah. Okay. Yeah. So I'll end with this recitation drawn from that chapter called Life and Death. Do you really know how precious life is? The total number of people who have ever been born is about 100 billion. Yet the genetic code that generates viable versions of us is capable of at least 10 to the 30th variations. That astronomically huge number is a 1 followed by 30 zeros, providing a million, trillion possible souls. Run through them all, and eventually we end up with you again, or at least your twin. But that won't happen anytime soon. So far, our branch of the tree of life has produced no more than 0.0000000000001% of all possible humans, forcing the conclusion that most people who could ever exist will never even be conceived. Each of us, for all practical purposes, is unique in the universe, now and forever. Being alive is the time to celebrate being alive every waking moment. Along the way, why not strive to make the world a better place today than yesterday, simply for the privilege of having lived in it? On the whole, I don't fear death. Instead, I fear a life where I could have accomplished more. An epitaph worthy of a tombstone comes from the 19th century educator, Horace Mann. I beseech you to treasure up in your hearts these my parting words. Be ashamed to die until you have scored some victory for humanity. Our primal urge to keep looking up is surely greater than our primal urge to keep killing one another. If so, then human curiosity and wonder, the twin chariots of cosmic discovery, will guide us to become better shepherds of our own civilization. Yes, life is better than death. Life is also better than having never been born. But each of us is alive against stupendous odds. We won the lottery only once. We get to invoke our faculties of reason to figure out how the world works. But we also get to smell the flowers. We get to bask in divine sunsets and sunrises and gaze deeply into the night sky they cradle. We get to live and ultimately die in this glorious universe. Thank you, Tampa. To listen to astrophysics. I'm deeply moved and honored, but I'm especially hopeful. This gives me hope that all of you care about science and you know and understand what role science will play as the future of civilization pivots on the brink of self-destruction or of prosperity and health and wealth for all. So please just you know what you have to do out there, especially at the holiday dinners. In Florida, even though I'm not religious, I'm praying for you. All right, guys, thank you.